Hello everyone. So now we will study RC circuit with the current input. Okay. Previously we were applying voltage source. Now we will apply the current. So this is the circuit. The switch is closed at t equals to 0. So how you can make the circuit? Basically, you can replace the circuit with the current source, a resistance R, capacitance C, VR and VC. The current source is 5 UT, right? Because it is closed at t equals to 0. So this is given at 40 greater than 0 only. So this is 5 UT. So tell me, what will be the value of VRT? VRT will simply be the current. How should I? Let's just call this current as IT. Okay. So VRT will simply be IT into R. It would be 5R UT. Very simple graph, right? What will be VRT? VRT is simply the current. Current will always flow 5 ampere. Through the resistor, 5 ampere current will flow, right? Always 5 ampere current will flow. So simply the graph will be initially 0, then rises to 5R. So 5R, this is the graph of VRT, right? This is the graph of VRT. Why it is not exponential? Why is it not exponential? First thing is that this is not a first order equation, right? There is no differential equation. The second thing, the current is always same. When we were studying this RC circuit, with the voltage input, what was happening? Initially the current was 5 by R. Then it was gaining some voltage, let's assume 0.1. The current was getting reduced to 4.9 by R. Then it was getting reduced to 4 by R, 3 by R. Every moment the current was changing. Here there is always the same current, right? Here the current is same always, right? If this is this 5 UT current is always flowing through the resistor, and the same current is always flowing through the capacitor. So now talking about VCT. So what will be VCT? Same current 5 UT always flows through the capacitor. Flows through the capacitor. That means your VCT would be 1 by C integration I dot dt. From where to where? From 0 to time t, right? So 1 by C integration 0 to t 5 ut dt. So it would be 5 by C RT, right? Or you can write it is 5 by C, 5t by C into ut, right? What is the integration of step? 5 is the common, integration of step is the ramp, or you can write it RT, you can write TUT. So basically it is this graph only, but not defined for t less than 0, always defined for t greater than 0, right? So what will be your VCT? Okay, there is no space, so I guess I can make the graph of VCT here only. VCT from 0 to 5 by C. So from 0 to it keeps on rising, right? It keeps on rising like this. And what is the slope? Slope is 5 by C, right? Theta. Slope is 5 by C. Okay. So this is the slope. Okay. Now this is the question. The switch is closed at t equals to 0. You have to find VR, VC, IC, IR. Everything we will comment on that. Okay. Same current is there. We have to comment on VR, VC, IC, IR. Everything we will comment on. Just a second. I guess I will have to change the setup. Yeah. So let's make the circuit. Let me pause it and then make. So first what we will do, we will solve by the equations, then we will see what is actually happening in the circuit. So this is the circuit. So let's just comment on VC first. Tell me what is the value of VC at t equals to 0 plus 0 voltage. So it is 0 voltage only. What will be the VC value at t equals to infinity? Tell me what will be the value. This will be open circuited, right? The capacitor voltage will be open circuited. So this complete 5 ampere current would be flowing here. This will be open circuited, so the complete 5 ampere current will be flowing here. So whatever the voltage, VR voltage you are having, the same voltage will be across VC. At infinity, what is happening is that this is 5 ampere current source you are having. This is the resistor you are having. This is the resistor you are having. This is open circuited. This is open circuited. Right? This is the 5 ampere current source. Now the complete current is flowing here. Right? This complete current is flowing in the same current is flowing in the resistor. So what is the drop here? 5R. Now since there is no drop across this resistor because it is open circuited, so there is no drop across the resistor. So same voltage drop will be across VC only. This is 5R. Okay. Along with that, let's comment on IC as well, because you don't really know what is IC. If IC is constant, if IC is always constant, that means the capacitor will linearly charge. But is IC constant here? Is IC constant? Tell me what is the value of IC at t equals to 0 plus. Write it in your rough notebook, then only you need to see the answer. What is the value of IC at t equals to 0 plus? 5 ampere, 2.5 ampere, 0 ampere. 2.5 ampere. Why so? Because what is happening at t equals to 0 plus? This is a 5 ampere current source. In parallel to that, we have a resistance R. Then another resistance R we are having, and the resistance is, and the capacitor is short circuited, right? Capacitor is short circuited. This is resistor R, this is resistor R, this is 5 ampere current source. So here, this current is your IC current. Resistor R, this resistor R is short circuited. So 5 ampere current is divided into two parts. So IC 0 plus is 2.5 ampere. What will be IC infinity? The capacitor will be open circuited, so it will be 0 ampere. So here the current is not constant. This is at t equals to 0 and this is at t equals to infinity. So what do you see here? Initially the current was 2.5 and at steady state it was infinity. The current is not constant. So we can say there will be exponential response. Here in this circuit, what do you see? Initially the current was 5 ampere and always it will be 5 ampere. Because the same current will be flowing here. Always it will be 5 ampere. But in the previous problem, what do you see? Initially it was 2.5 ampere, then it goes down to 0 ampere. Now, one important thing we have forgot here. What is the time constant of the circuit? By the waveform, you can tell the time constant. What is the time constant of the circuit? Look, the time constant will be defined as per the voltage. Okay. If I am considering this is my output voltage, if I am taking my output at resistor, I will connect two pin, okay, and I am taking my output. So this is what I am telling my output. So I am telling my output as at resistor. So what will be my time constant? Here my time constant is 0 second because it is stabilized immediately, and here my time constant is infinite second because it is never getting stabilized. So in a circuit, the time constant depends on the output from where you are taking. Are you getting my point? The output from where you are taking it. Are you getting my point? Let's just assume I am taking my output from here. So what will I see? From here I will see my R equivalent. What is my R equivalent? That is R, or R effective I will say. What is my C effective here? From here I will see. What will happen to current source? Current source will be open circuited. The current source will be open circuited. So this C will be open ended. Open ended C means 0. That means 1 by j omega C. Open ended means infinite impedance. If it is infinite impedance, that means it has to go to 0. Open ended means infinite impedance. If impedance is infinite, that means capacitor has to go to 0. So if capacitor is 0, that means C effective is 0. So what is your time constant? Time constant is 0. Okay, so the time constant is 0 second. And if you are taking your output from here, okay, from here if you are taking, so what is your C effective? C effective is C. What is your R equivalent? Tell me what is your R equivalent? From here you will see. So the current source is open circuited. If the current source is open circuited, that means you will see infinite impedance, right? Current source is open circuited, that means you will see infinite impedance. So what is your time constant? That is infinite second. Are you getting my point? Also by waveform you can see it is never going to stabilize. So infinite second is time constant. Here in the waveform you can see it is stabilizing very quickly. So time constant is 0 second. Okay. So depending on the output, your time constant can change. Here we are taking time constant at the, here we are taking the final output at the capacitor. So the time constant is infinite second. Here we are taking the output at resistance. So time constant is 0 second. So why in the previous analysis we never saw circuits like this? Let's just take an example. We take this circuit. Okay, we never talked about anything. We just said that like we never talked about the output. We just said that the time constant of this circuit is RC. Why so? Let's just assume you are taking your output here. What will happen? You will short circuit this. You will short circuit this. What is your R effective? R equivalent you can say R. And if it is shorted, that means this C will come in parallel. So basically from here you will see C effective, that is C only. So time constant is RC. From here if you see, from output, this is your output. From here what do you see? C effective is C only. What is R equivalent? Since this is shorted, your R equivalent is R only. So time constant is RC. Are you getting my point? Got my point? That's why we never saw where we are collecting the output. Let's take more examples. This was one more circuit that we have studied. Okay. Let's assume I am taking my output from here. So what will you see? Taking my output from here, this will be shorted, right? This will be shorted. So this R and this R will come in parallel, right? And this C will also come. So R equivalent you are seeing R by 2. C effective is C. So what is time constant? RC by 2. From here if you are seeing, if you are collecting your output from here, so what do you see? C effective is C. What is R equivalent? Both will come in parallel. So it would be R by 2. So it would be CR by 2. Are you getting my point? So in case of current source, you can't really say this is the time constant of my circuit. Okay. First you need to define the output. If you are collecting the output, in case of a current source, if you are collecting the output at some point here, so time constant will be different. Here the time constant will be different. So here in this case you see there are two time constants with respect to the output. So always the time constant is defined with respect to the output where you are actually taking the output. Okay. In this circuit we will see the time constant now. Now for VC and VR we are seeing the time constant. Okay. IC and VC. For IC and VC we need to see the time constant. So where is our IC and VC? This is our output, right? What we will do? We will open circuit the current source. Okay. Now we are talking about the time constant. What we will do? We will open circuit the current source. The current source is open circuited. This is R, and this is capacitor C. Right? These two will come in series. So what is my R? This is my output. Here I am taking the output. So what is my R equivalent? That is 2R. What is my R equivalent? That is 2R. What is my C effective? That is C. So what is my time constant? That is 2RC. Okay. Time constant is 2RC. So VC is rising from 0 to 5R and IC is decaying from 2.5 to 0. Okay. So if we want to write down the equation of VCT, from 0 to 5R it is rising. So 5R e to the From 0 to 5R it is rising. So 5R 1 minus e to the power minus t upon 2 ut with time constant being 2RC. And what about ICT? What about ICT? Initially the current was 2.5, then it goes down to 0. So from 2.5 to e to the power minus t upon 2 ut with time constant being 2RC. Okay, so now we can make the waveform of these two. It will be exponential because the time constant is a finite value. If it is 0, then mean it is stabilized very quickly. If it is infinity, that means it is linearly charging. If it is some value, that means it will be exponentially charging. So all your concepts are crystal clear, right? In transient, the concept has to be crystal clear. So every subject that needs the crystal clear concept, I will teach you in the similar manner. Okay. So from 0 to 5R we will rise. And what about ICT? From 2.5 to 0 it goes. Time constant is 2RC. Time constant is 2RC. Okay, well and good. Yeah. Now we will comment on what? VR and IR. If we simply comment on VR, we can comment on IR as well. So let's make the same circuit again. Okay, I guess we can make it on the next page. Okay, let me copy on the next page. So now we are commenting about VR and IR. Both of them we are commenting about. Okay, VR and IR. Okay, so tell me, what will be the IR value at t equals to 0 plus? What will happen? This capacitor will be shorted. This capacitor will be shorted, so the 5 ampere current will be divided into 2 resistors. So it would be 2.5 ampere. Right? What will be the IR value at t equals to infinity? What will be the IR value at t equals to infinity? This capacitor will be open circuited, so the complete current will be flowing through the resistor. So it would be 5 ampere. Similarly, on VR also you can comment at t equals to 0. What will be VR? VR will be 2.5 into R, so it would be 2.5 R. And what will be VR at t equals to infinity? It would be 5 R. Are you getting the point? Very simple. Capacitor is shorted. The current is divided into two parts, R and R. 2.5 ampere, 2.5 ampere. Okay. The capacitor is open circuited. That means the complete current is flowing through the resistor. Okay. We will also see what is really happening in the circuit, but in the later part of the video. Okay. So now we are just making the waveforms and writing down the equation. So what is the equation of IRT? It is going from 2.5 to 5. So it would be 5 minus 2.5 e to the power minus t upon 2 with time constant. Tell me the time constant now. Time constant. We have to comment on the time constant. Current source will be open circuited. So simply a resistor, another resistor, another capacitor. So this is where we are collecting the output. Right? What is R equivalent? R and R in series. So what is your R equivalent? 2R. What is your C effective? Only one capacitor, that is C. So what is time constant? 2RC. Right? Same time constant. Exponential response, same time constant. Time constant is 2RC. What about VRT? What about VRT? It would be the same, just R will be there, nothing else. So 5R minus 2.5R e to the power minus t upon 2 ut. Of course, ut will be there with time constant being 2RC. So I will just make one waveform, no need to make both of the waveforms VR and IR. I will just make the waveform of IR. Okay. So for IR waveform, first from 2.52 it goes up to 5 volt. Okay. From 2.52 it is going up to 5 volt, and with time constant being 2 RC. Okay, well and good. So this is the time constant. So this is the complete analysis. Now let's see what is actually happening in the circuit. I am not going to write it. I will just tell in the theory. Okay, you listen it very carefully. If you want to write, you can write it on your own. So what is happening? Also, first you can think on your own. So let's see. Initially the capacitor is shorted. That means 2.5 hour current is flowing. Okay, here 2.5 hour current is flowing. Okay, let's do it on a rough page so it will be more easier to understand. Okay, I will erase it later on, but let's just see the circuit. Let's just forget everything and just forget this. So what is initially happening? Initially this 2.5 hour current is flowing here. Now this 2.5 ampere current is flowing here. Now this 2.5 ampere current charges the capacitor. Let's assume initially it is 0. Let's assume it is charged to some voltage, that is 1 volt. Okay, let's assume it is charged to 1 volt. So now what will happen? Here we have V volt. Okay, initially 2.5 ampere current was coming, right? Now what is happening? This is driving some V by R ampere current, and this is driving some V minus Vc by R, right? Because of this current, this Vc value is getting increased. If this Vc value is getting increased, that means this current is getting reduced. If Vc value is increased, this V is constant. If this Vc value is increased, that means V minus Vc will be reduced. That means the current will be reduced. So slowly the current here is reducing. If the current here is reducing, from here we have 5 ampere current, that is fixed, and here the current is reducing, that means the current is increasing here. So initially it was 2.5 ampere current here, now it is increasing here, and here initially it was 2.5 ampere current, now it is decreasing. So it will keep on decreasing, it will go down to 0 ampere. Decreasing and decreasing, it will go down to 0 ampere. And when it will go down to 0 ampere? When the potential here and here are same. If the potential here and here are same, that means the current in this resistance will be 0 ampere. So when the potential will be the same, when the complete current is flowing here, that means here the potential should be 5 R, here also the potential should be 5 R. So when both of the potential are equal, that means the current here would be 0. So that means we will replace this with open circuit, then we can find the voltage drop across the resistor, that is 5 R. Are you getting my point? So voltage across the resistor is 5 R. Here also we have 5 R. So current is 0. That means all the current is taken by the resistor. Are you getting my point? So this is the actual analysis. Got it? Understood? Now you can solve this circuit by one more method. The same circuit by one more method. This circuit. What is that method called? Source transformation. Okay. I will just copy the circuit. We'll write method 2. Method 2. Okay. What I can do? I can apply the source transformation. First, this will be replaced with this circuit, and from there I can apply the source transformation. So if I apply the source transformation, so what I am doing, I am converting this current source into the voltage source. So this will be converted, this current source will be converted into voltage source. So what will be the value of voltage source? Current into the resistance, that would be 5R ut, and this resistance will come in series, that will be R. Okay. Okay. Now you can find these values as well. Okay. What are the values? This is VC. This is, forget it. Is this VR? Tell me one thing. Is this VR? Let's call this value as VR dash. This value is IR. This is IC. IR dash. This as IC dash. And this as VC dash. Okay. VC dash. So I will ask you one question that I have already explained in the network theorem part. Okay, I have explained this in the network theorem part. So I will ask you one question. So tell me, will this VR dash and IR dash is same? Is this IR dash and IR is same? Is this IC dash and IC is same? And this VC dash and VC is same? Which are the statements true and which are wrong? You need to tell me. Okay, just solve it in rough and tell me. Is this correct? No. Is this correct? No. Is this correct? Yeah. Is this correct? Yeah. Why so? The component which is getting converted, you can't find the voltage and current there. Applying the source transformation. I wrote it in a note, right? If you remember, this resistance is getting converted, right? So if this is the VR, you can't convert it and tell me this will be the VR. No, 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 no. This won't be IR. No. This will be different because this is getting converted. So whatever that is getting converted, you can't find the voltage and current across that component after applying the source transformation. Okay, just consider if this is a source resistance, so you can't really find the voltage and current in the source resistance because that is getting converted. So this is not same. If you need to find VR and IR, you have to solve this circuit only. You can't find VR and IR from this circuit. Okay, if you need to find VR and IR, you have to solve this circuit only. From here you can find only the two components, that is IC and VC, because they are not getting converted, right? This circuit is remaining as it is. This complete circuit is remaining as it is. R and C, this is remaining as it is, but this part of circuit is getting converted. Are you getting my point? So these two are correct, IC and VC, but VR dash and IR dash is not correct. Okay. So from here, if you need to find VC, how will you find? Simply a RC circuit with 2R resistance in series. So this can be replaced just simply an RC circuit with 5R UT voltage, simply an RC circuit with the voltage, resistance and a capacitance. Resistance value is 2R, capacitance value is C, and the voltage is 5R UT. So simply from 0 to 5R UT it will charge. So VC value will be from 0 to 5R UT, right? This VC value will be from 0 to 5R, from 0 to 5R it will rise. So where is VC? VCT, it is rising from 0 to 5R. What about IC? Initially IC was 5 by 2R, 2.5 by R, right? Initially IC was 2.5 by R, then it goes down to 0. So here also you can see from 2.5 IC value, where is IC? Yeah, here it is. From 2.5 to 0 it goes. Okay. Yeah, from 2.5 R by 2R, that means 2.5 to 0 it goes. So that's how you can solve the circuit as well. Okay. So by simply applying the source transformation, you can solve the circuit as well. So the problem looks simpler now, right? But you can't find VR and IR from source transformation. Can't find VR and IR from source transformation. VR from source transformation, right? So these two circuits we have studied. Now we will study this circuit. Okay. So first here we will comment on IR, IC and V0. So let me make the circuit. So this is the circuit. Instead of 5 ampere, I should have written 5 UT, right? So before starting this problem, I want to ask you one question. This is a current source of 5 ampere and this is a short circuit path. Okay. Now tell me, what is this value? What is the value of I? Is this 5 ampere, 0 ampere or infinite ampere? Three options are there. You need to choose one. 5 ampere, 0 ampere or infinity ampere? What is your answer? The current is 5 ampere only, right? If there is 5 ampere current, it will always give you 5 ampere current because this is a current source. And even if there is 0 volt across it, it will always give you 5 ampere current source. In case of voltage source, what happens? Even if there is 0 current flowing through it, whatever the current is flowing through it, it will always give you 5 volt. Even if the current is infinite, even if the current is 0, even if the current is 5 ampere, even if the current is 4 ampere, 3, 2, 100, 1000, it will always give you 5 volt. No matter whatever the voltage is there across the current source, even if it is 0, even if it is 100, even if it is minus 100, even if it is infinity, whatever the voltage is there, it will always give you 5 ampere current, right? So the current here would always be 5 ampere, always 5 ampere current will flow from here, right? So now tell me, what will be the circuit at t equals to 0? Circuit at t equals to 0. This is 5 ampere current source. This is a resistance R, right? This complete circuit will be shorted. This complete circuit is shorted. So tell me, what will be this current is IC, because at t equals to 0, capacitor will be short circuited. So tell me, what will be the value of IC? IC value at t equals to 0 plus would be 5 ampere, right? Because this complete current will be flowing through the short circuit path. The current here is 5 ampere, right? The current here is 5 ampere. Now this 5 ampere current sees two paths, resistance R and a short circuit path. So it will go to short circuit path only. So the IC current is 5 ampere. It is not infinity. So the circuit looks like something like this. Circuit looks something like this, 5 ampere and a short circuit path, right? This is how the circuit looks like, right? Now you will not say there is infinity current. If there was a voltage source, we would have said there is infinity current, V by 0 resistance, infinity. But this is already a current, so it is 5 ampere only. So it is not the case of infinite current. It is the case of a finite current, that is IC equals to 5 ampere, right? So IC equals to 5 ampere. IC 0 is 5 ampere. What is the VC value at t equals to 0 plus? That is VC value or V0. We are only commenting out V0. V0 value at t equals to 0 plus, that is 0 volt. What is the IR value at t equals to 0 plus? Since no current is flowing here, the IR at 0 plus is 0 ampere, right? This is the condition at t equals to 0 plus. Now let's talk about the time constant. Tell me, what is the time constant? Just make a small box here. We can talk about the time constant here. Tell me, what is the time constant? For time constant, open circuit the current source. Open circuiting the current source. We will make a resistor. There are two capacitors this time. C1 and C2. This is the resistance. C1, C2 comes in series. So from wherever you connect the output, from here you connect the output, from here you connect it. In case of exponential response, the complete circuit will be exponential. Okay, this line is not actually completely true. So let's just forget that line. The previous line is wrong actually. So from wherever you connect the output, let's assume I am connecting my output from here. Okay, I am collecting my output from here. Okay, now tell me, what will be my C effective? C1, C2 are in series. So C1, C2 upon C1 plus C2. right? What will be my R equivalent? C1 C2 will be one capacitance, that will be C1 C2 upon C1 plus C2. These can be converted into one capacitor, right? That's why it is a first order circuit, not second order. Even though there are two capacitors, but still it is a first order circuit. Okay. What is R equivalent? R equivalent is R. So what is the time constant? R into C1 C2 upon C1 plus C2. So this is our time constant. Okay. Circuit at t equals to 0 we have discussed. Circuit at t equals to infinity. So what will happen? 5 ampere current source. Resistance R is there. The capacitor will be open circuited, right? Capacitor will be open circuited. Right? So this value will be V naught. The capacitors will be open circuited. So the complete current will be flowing through this resistance. So here the voltage drop would be 5R. Right? So now what will happen? Now tell me what will be the value of V naught? If this is grounded, what will be the potential of this point? 0. What will be the potential of this point? That will be 5R. Do you know the potential of this point? No, because they are open ended, right? They are open ended nodes. You don't know the potential of this point, but you know one thing: 5R voltage is applied to two capacitors. In the previous video, previous to previous video it was there, or in the previous video only, when we solved the numerical example, we saw that finally the voltage was getting divided into two capacitance, and this is what is happening here. So 5R voltage, this 5R voltage is getting divided into C1 and C2. This 5R voltage is getting divided into C1 and C2, right? This is what your V naught is. So what will be your V naught? Your V naught, here I will write, V naught at t equals to infinity would be 5R into C1 upon C1 plus C2. I should write it in better manner. 5R into C1 upon C1 plus C2, right? This will be your V naught at t equals to infinity. What will be the value of IC at t equals to infinity? That will be 0 ampere. Now some students who think a lot, they may think that the current will be impulsive, IC, because they will say that 5R voltage is coming and then here the capacitors are there, so we can say the current will be impulsive. Is the capacitance shorted here? Capacitance are not shorted here. They are providing very high impedance. They are open circuited actually. The capacitance are open circuited, not short circuited. You can't say the current will be impulsive. Okay, the capacitance are providing very high impedance. Okay, so 5R by very high impedance. That means very low current, that is equals to 0 ampere. Are you getting my point? For dividing the potential, I have made the circuit like this, but actually they are nearly open circuited. So IC infinity will be 0 ampere only. And what about IR infinity? That would be 5 ampere. You know the time constant, you know the values, you can make the graph, you can write down the equation. I will just make the graph. You can write down the value of equation of IC, because IC is starting from 5 ampere and going down to 0. From 5 ampere to 0. What about V naught? It is going from 0 to, it is going up to this value. 5R C1 C. Okay, I will just write it. So ICT, for ICT, initially ICT was 5 ampere and then goes down to 0. 5 into e to the power minus t upon 2 ut. What about VC V naught t? It goes up to 5R C1 upon C1 plus C2 and starts from 0 ut. What about IRT? It starts from 0 and goes up to 5 ampere. We are talking about IRT, right? IRT. So goes up to 5 ampere and starts from 0. this is ampere, this is volt, this is ampere. Now you can make the graph on your own. I will not make the graph now, or should I make the graph as well? No, you can make the graph from 5 to 0, from 0 to 5R C1 upon C1 plus C2, and for IR from 0 to 5. So these will be the graphs. Okay. So I will draw the graph as well. Why should I leave anything? 3 graphs I have to make. Like some people will be reading from notes only. They will not be reading from the lectures. So for them I am writing it down. Okay. ICT, V0T and IRT. ICT from 0 to 5. What about V0T? V0T was also from 0 to ICT is actually from 5 to 0. So this I have made IRT actually. This is IRT, right? From 0 to 5. ICT I will make here. ICT is from 5 to 0. From 5 ampere to 0 ampere. Right? And VCT, V0 actually from 0 to a certain value. The value is 5 C1 upon, it is 5R C1, no? 5R C1 upon C1 plus C2. 5R C1 upon C1 plus C2. Okay, so these are the graphs. Okay, so we can see more examples since we have time left. So we will see more examples of RC circuit. Okay, now again with the voltage source. So how will you replace this circuit? Here we need to comment on only two things, that is V0T and IT. Okay, so how will you replace the circuit? This is C1. This is R. This is C1. This is 5 UT. I guess now you guys are very much comfortable with whatever is happening in the circuit. I hope you guys are finding it now easy to comment on the circuits, right? Because we have seen many examples and very deeply we have studied. If we have just studied open circuit, short circuit, voltage is always conserved, or all these things, we have studied very deeply. Impulsive current we have seen, step current we have seen, everything we have seen, step voltage we have seen. So I guess now guys are very much comfortable, right? So tell me, what will be the value of V0? First tell me the time constant of the circuit. First we will comment about the time constant. Is it a second order or first order? It's a first order circuit only. Why is it so? Because the C1, C2 are in series. What will happen? We will short circuit the voltage source. Voltage source is shorted. This is C1. Then we will have a resistance R. Then we will have a C2. This is resistance R, C2. Right? So C1, C2 are in series. So R effective is R equivalent, I should say. Wherever you connect the output, if we are connecting the output here, so R equivalent is only R and C effective is C1, C2 being in series, it would be C1, C2 upon C1 plus C2. So what will be your time constant? R C1, C2 upon C1 plus C2. That will be your time constant. Okay. This will be your time constant, first order circuit only. Okay, now comment on the things. Tell me what will be the value of I at t equals to 0 plus. Tell me what will be the value of I at t equals to 0 plus. IC you can say, or I you can say. I will call it IC. Okay, instead IC we should say. So IC at t equals to 0 plus. What will be the value? C1, C2 both will be shorted. The value will be 5 by R. It is not infinity. So 5 by R ampere. What will be the value of V naught T? Instead of V naught, should we comment on VCT or V naught T? We should, instead of that, we should comment on VCT. Okay, let's comment on VCT only. Let's call this VCT. Okay, instead of taking complete output, you can comment on complete output as well, but we are now commenting on VCT. Okay, so tell me initially what will be the value of VCT? VC at t equals to 0 plus. It will be 0 volt only, right? 5 by R current is flowing, so it will be 0 volt only, because the capacitor is shorted, C1 is shorted, C2 is shorted. So VC at t equals to 0 plus is 0 volt only. Okay. Now the thing is, circuit at t equals to infinity. Circuit at, this is an interesting point now. Circuit at t equals to infinity. 5 volt here. C1 will be open circuited. C2 will also be open circuited. C1, C2. How will you divide the potential now? Because if this is grounded, this is 0, good. This is 5. Do you know about this potential? Do you know about this potential? No, you don't know about these two potential. Why so? Because both are open-ended nodes. Open-ended nodes. Okay. So now how will you divide the potential? We know that potential is going to be divided, right? In the previous examples that we have seen, we saw only two things. Capacitors. We saw only two capacitors, C1, C2. Now there is a resistance as well. So what you will do of this resistance? That is the main task. Tell me one thing. At t equals to infinity, that means steady state. So at steady state, omega is 0. That means resistance provided by the impedance provided by the capacitance, impedance by capacitor is very high, right? So the series combination of RC RC2, it is series combination of RC2 can be replaced with a single capacitor. Why so? Because this is a finite value and this is very high. So very high plus finite will be equals to very high only. So this will be replaced with a single capacitor, that is C2. So what will be your equivalent circuit? Equivalent circuit at t equals to infinity. So basically C1, that C1 will remain there as it is and C2 will come here, right? And there will be this 5 volt. Now will the current be impulsive? Current will not be impulsive, right? We are commenting on this VC. Will the current be impulsive? No, current will not be impulsive. Why so? Because the capacitors are open circuited here, not shorted. Okay, so the current will not be impulsive. So what will be your VC at t equals to infinity? It would be 5 into, and yeah, here we can comment about IC actually. So IC at t equals to infinity would be 0 ampere. Why so? Because these are providing very high impedance, they are open circuited. They are providing very high impedance, they are open circuited. And what will be VC at t equals to infinity? That would be 5 C1 upon C1 plus C2. Okay. So from 0 to 5 C1 upon C1 plus C2 it is writing. So let's comment on VC. VC 0 plus is, first it was 0 volt because they were shorted. Then it was rising to 5 C1 upon C1 plus C2. What about IC? IC initially was 5 by R ampere, right? And then it was rising to 0 ampere, right? So let's comment down the value of VCT from 0 to some value it is rising. And what about ICT? From 5 by R to 0 it is going. What is the time constant? That is R. What is the time constant? R C1 C2 upon C1 plus C2. From 5 by R to 0 it goes. And from 0 to 5C1. So are you understanding those circuits? Okay, well and good, very easy. Let's move on to next circuit. You will solve it on your own. Okay, we will comment on VR2, we will comment on V0, also we will comment on the current. So you should solve the circuit on your own. IT. Okay. So initially tell me what will be the value of V0. First tell me the time constant. What will be the time constant? Time constant would be, this will be shorted, R1 R2 will come in series and C1 C2 will also come in series. So R equivalent would be R1 plus R2. And what will be C effective? C effective will be C1 C2 upon C1 plus C2. What will be your time constant? R1 plus R2 into C1 C2 upon C1 plus C2. Okay, this will be your time constant. Got it? Now we need to comment on the circuit at t equals to 0. At t equals to 0. I will not make the circuit this time. Tell me what will be the value of IT? I at t equals to 0 plus. C1 will be shorted, C2 will be shorted. R1, R2 will come in series. The current simply be 5 upon R1 plus R2. What about the current we have talked about? What will be the V0 value at t equals to 0 plus? C2 is shorted, C1 is shorted. So R1, R2 are in series, simply potential divider. 5 into R2 upon R1 plus R2. Simply potential divider, nothing else. 5 into R2 upon R1 plus R2. This is V0 at t equals. What will be the value of VR2 at t equals to 0 plus? VR2 at t equals to 0 plus and V0 at t equals to 0 plus will be the same because capacitor is having 0 voltage. So VR2 and V0 at t equals to 0 plus will be the same. That would be 5 R2 upon R1 plus R2. Now let's talk about circuit at t equals to infinity. At t equals to infinity. 5 volt is there. This is open-ended. This is a resistor. This is open-ended. Right? What will be the drop here? That will be 0 volt. This is R1. This is R2. This drop will be 0 volt. The current will be 0 ampere. Right? This is C1. This is C2. This is your V0 and VC2 we are not talking about. Okay. Yeah. So now you know the potential of this point. If this is 0, this will be 0 volt. You can use a different pen. This will be 0 volt and this will be 5 volt. Do you know the potential of this point? No. You don't know the potential of this point? No. Although the drop here is 0 volt, but you don't know the potential of these 2 points, right? The drop across the resistor R2 is 0. That means the drop of this point and this point will be the same, but you don't know what is the value. Why so? Because they are open-ended. Open-ended nodes. So what will happen? Open-ended nodes. At t equals to 0, now what we will see? If there is ambiguity, what do we do? At t equals to infinity, omega equals to 0. That means series combination of RC will be replaced with a single capacitor, right? So simply 5 volt will be divided into C1 and C2. This is 5 volt, this is C1, this is C2, right? Basically this will be your V naught only now, because your VR at t equals to infinity is, this was your VR, right? VR2, whatever we say, VR2 at t equals to infinity is 0 volt. What will be your V naught at t equals to infinity? That would be 5 C1 upon C1 plus C2. And what about I at t equals to infinity? That would also be 0 ampere, not impulsive, because they are providing very high impedance. Okay. So basically now we will make the graph. You can write down the equation on your own, but now we will make the graphs. If you can make the graph, if you know the time constant, you can write down the equation as well. Because you only need to know 3 things for writing down the equation: t equals to 0, t equals to infinity, and the time constant. These 3 things you need. V naught t, it, V naught t, it, and VR2t. VR2t and it. Right? So what about, first we will comment on it. It is 5 R1 upon R1 plus 5 upon R1 plus R2, then goes down to 0. Okay, wait. We are talking about it now. So it is, first it has some value, that is 5 upon R1 plus R2. You can solve all this circuit by Laplace transform as well. Okay, every teacher teaches is with Laplace transform. Okay, but it will take a lot of time and it won't develop your brain. I want your brain to be developed. Okay, that's the important thing. You should have the intuitions so that you can solve the circuit correctly, also quickly. If you solve by Laplace, there is high chance you will get it wrong in the exam, because there will be a lot of pressure and you will be solving very quickly, and one calculation mistake will ruin all the hard work, right? But this is the intuition. Here you are just completely thinking and you won't get it wrong if you are thinking, right? I have given you enough intuitions. Now you can think of any circuit by your own. When we will solve this problem, you will understand why I have spent so much time on this. Okay. So this is about IT. Now let's comment on VR2T. VR2 goes down to 0 and starts from some value, that is 5 R2 upon R1 plus R2. It starts from 5 R2 upon R1 plus R2. Now what about V naught T? V naught T initial was V naught at T equals, okay, V naught T is the complete potential. So it is 5 R2 upon R1 plus R2. Then it goes to 5 C1 upon C1 plus C2. Now it depends on the value of RC, how the V naught waveform look like, right? So for V naught, I will have to take conditions. Because V naught T, in V naught T there is ambiguity. So let's see. V naught at T equals to 0 plus is what? 5 C2, 5 C1, or whatever it is. At T equals to 0, it is not C1. It is 5 R2 upon R1 plus R2. 5 R2 upon R1 plus R2. And what is V naught value at t goes to infinity? That is 5 C1 upon C1 plus C2. Okay. So there are two chances. It can rise, it can decay, it can be equal. Right? You can write it down as 5 upon 1 plus R1 by R2. You can write it down as 5 upon 1 plus C2 by C1. Right? There will be basically three graphs. First, in one graph it can rise R1 by R2, and in the other graph it can decay down in the third graph it may remain flat. Third graph it may remain flat. Right? This will be your V naught T. This condition we clearly know, R1 C1 equals to R2 C2. Right? Because R1 C1 equals to R2 C2, then R1 by R2 is equals to C2 by C1. So this value and this value will be same. So initial and final value will be the same. Right? Initial and final value will be the same. So in this case, what will be the time constant? That is also one important thing, and the time constant will be 0 second in this case. Right? In all the other cases, the time constant would be the same. That is R1 plus R2 into C1 C2 upon C1 plus C2. R1 plus R2 into C1 C2 upon C1 plus C2. And here as well the time constant would be the same. R1 plus R2 C1 C2 upon C1 plus 2. Now tell the conditions. Here this value is larger. That means I guess it would be R1 C1 is lesser than R2 C2. If C2 by C1 is larger, this will be lower. So V infinity will be lower. So this condition will be R1 C1 greater than R2 C2. R1 C1 greater than R2 C2. Why so? Because R1 by R2 would be greater than C2 by C1. If this value is larger, that means overall value will be low. So at t equals to 0 plus we are having low value, and at t equals to infinity we are having high value. And this condition would be R1 C1 is lesser than R2 C2. Okay, that means C2 by C1 is larger, that means this value is larger, so overall value will be low. So infinity value is low and 0 value is high. So that's how the graph will go. Have you got the point? Have you understood the circuit? I hope you have understood the complete circuit. Okay, so these were also two good examples. If there are more examples left, let's see. Okay, so this is a whole new concept. There are three circuits A, B and C. The capacitor C1 is charged to 5 volt. You have to find the voltage across C1, C2 and the current. There are three circuits. We will analyze the circuit one by one. Okay, so let's start with circuit A. We have time left. We can do it in this lecture as well. Okay. Yeah, so this is our first circuit. C1 capacitor, C2 capacitor, IC1 current, IC2 current, VC1 voltage, VC2 voltage. VC1 is already 5 volt. Okay, the switch is closed at t equals to 0. What is happening at t equals to 0? Circuit at t equals to 0. Or I should make it at low. Circuit at t equals to 0. This capacitor will be replaced with a 5-volt battery, right? Initial voltage will be replaced with its initial voltage, will be replaced with a 5-volt battery, right? This will be replaced with a 5-volt battery. Switch is closed, so short circuit. This capacitor is having no voltage, it will be shorted. अरे यार, it will be shorted. Okay, this will be shorted. Okay, so now tell me what is the current flowing now. This is 5 volt, this is shorted. Even if VC2 was 1 volt, what will be the current? Let's assume your VC2 initially was 1 volt. So 5 volt and 1 volt. What will be the current? Current is 5 by 0. Infinite. Impulse current. That means sudden change in capacitor voltage. Sudden change in capacitor voltage. We don't know the value of current. We don't know the impulse current, but there will be sudden change in capacitor voltage, that we know, right? Even if VC2 was having 6 volt, what will be the current? 5 minus 6 by 0. Impedance will be 0, na? There is no resistance involved, so impedance is 0, right? So the current would be infinity only. So the current would have been infinite only. So now the current is infinity, impulse current is flowing, that means there will be sudden change in capacitor voltage, right? So how you can find the sudden change in capacitor voltage? So this is your circuit. C1, C2. This will be VC1, this will be VC2. This is already charged to 5 volt. We will apply charge conservation. Charge conservation. How will apply? Charge before switching. Switching equals to charge after switching. What was the charge before switching? It was C1 into 5. What will be the charge after switching? After switching, both of the capacitor has to have one single voltage, right? After switching, VC1 has to be equals to VC2, right? So C1 VC1 I will write plus C2 VC2 I will write. After switching, why it has to be equal? To follow the KVL, right? Potential has to be equal. So after switching, VC1 equals to VC2 equals to some voltage VC. So after switching, both of them has to be equal. So initial charge 5 C1 is equals to C1 plus C2 VC. So VC would be 5 C1 upon C1 plus C2. So from 0 to suddenly it will charge to this value. So this will go from 5 to this value. This will go down. VC1 will go down from 5 to this value, and VC2 will go up from 0 to this value. We will write down a short note here. Okay, note. Let's assume this was the condition. The switch is closed at equals to 0. This was C1, this was C2. This was having V1 voltage and this was having V2 voltage. And let's just call this potential as V naught. So V naught at t equals to, so how will you apply the charge conservation now? C1 V1 initial charge at this is C1 V1. What is the initial charge at this? C2 V2. What will be the final charge? C1 C2 both will come in parallel and both of them will have a common voltage, that is V0. So your V0 would be C1 V1 plus C2 V2 upon C1 plus C2. Are you getting this point? Always see the direction. Okay, if V2 was negative, you would have written C1 V1 minus C2 V2. So initial voltage, always see the direction. C1 V1, C2 V2, initial voltage upon what will be the final. At final, both of them will be having V0 voltage. Both of them will be having the same voltage V0. So C1 V0 plus C2 V0. So that would be C1 plus C2 into V0. So V0 would be C1 V1 plus C2 V2 upon C1 plus C2. What we did? Initial charge plus final charge. So both of them will be having the same voltage. So this will happen. Okay. So let's make the graph. So if I make the graph of VC1, what will happen? And then I will make the graph of VC2, what is happening. Okay. So this we are talking about VC1 versus T, and then we are talking about VC2 versus T. So in case of VC1, first we are coming from 5 volt. We are coming from 5 volt, and then we are going down to 5 C1 upon C1 plus C2. This is 5 volt and going down to 5 C1 upon C1 plus C2. And what about this? We are in case of VC2, we are coming from 0 and then we are going up to 5 C1 upon C1 plus C2. No transient. 5 C1 upon C1 plus C2. What is the time constant? 0 second. What is the time constant? 0 second. Now tell me what about IC1 and IC2. What is IC1? This is your IC1, right? And this is your IC2. One thing we know here is that IC1 is negative of IC2. IC1 is flowing in this direction, IC2 is flowing in this direction. Can you find IC2? IC2 will be actually positive because it is having the C2 capacitor is getting charged. If C2 capacitor is getting charged, that means the current is flowing into the C2 capacitor, right? C2 capacitor is getting charged, that means the current is flowing into the C2 capacitor, and C1 capacitor is getting discharged, that means current is flowing out of the capacitor, right? So I will write it down. C1 capacitor is getting discharged. That means current flowing out of the capacitor. Current flowing out of the capacitor. And C2 cap is getting charged. That means current is flowing into the capacitor. Current flowing into the capacitor. That means here what you will see, IC1 is negative, right? Because we are showing it flowing into the capacitor, but it is actually flowing out of the capacitor. So IC1 is negative and IC2 is positive, right? Now I will just make the waveform. Now how will you make the waveform? That's interesting. So this will be for IC1, this will be for IC2. The current will be impulsive. What will be the magnitude? I want you to tell me that. For IC1 we will have a negative value, and for IC2 we will have a positive value. This will be your IC1 and this will be your IC2. What will be the magnitude? C1 capacitance, like what will be IC? IC will be C dVc by dt. The change in capacitance voltage, the change in capacitance voltage from let's just call this potential as V dash. We are calling this potential as V dash so that we can actually write it. Okay, we are calling this potential as V dash. So what is happening? This is going from 5 to V dash. So what is the change? See, what is the change from 5 to V dash? Now, is this value positive? Yeah, this value is positive. So we have to take a negative sign. Actually, change is written as, let's forget it. Change is written as, how change is written? Change is written as final minus initial. What is final? V dash. What is initial? 5. So this will be your magnitude. So, and C1 will also be here. So C1, what is the change in potential? I should have written like this. Capacitance is C1. What is the change? Final voltage is V dash. What is the initial voltage? That is 5. So C1 into V dash minus 5. Right? So it will be C1 into V dash minus 5. That is already showing that this is a negative value. Okay. Here your V dash is, what is V dash? 5 C1 upon C1 plus C2. 5 C1 upon C1 plus C2. So actually solving this will you will get, after solving this you will get 5 C1 C2 upon C1 plus C2. Okay. So I think 5 C1 upon C1 plus C2. What is your V dash? V dash is 5 C1 upon 5 C1 upon C1 plus C2. So let's see it. 5 C1. I'm just trying to solve it. Okay. C1 upon C1 plus C2 minus 1. Okay. So it will be 5 C1 C2 minus value will be there. Okay. So you will get, this is your actually V dash. So you will get minus sign here. Minus 5 C1 just by solving it, nothing else. Now what will be the voltage here? It will be C2 into, and this is impulsive, for already an impulse is there, C2 into the change in the capacitance voltage, change in the capacitance voltage from 0 to it is going to V dash, right? From 0 to it is going to V dash minus 0. So it would simply be 5 C1 upon C1 plus C2. This we are talking IC2. Here also you can see IC1 is negative of IC2, right? Understood? All the things you have understood. IC1, IC2, VC1, VC2, right? Let's take next circuit, that is circuit B. Let me pause and make the circuit. So this is the circuit B we are having. Okay. So tell me what is happening. Circuit at t equals to 0. Circuit at t equals to 0. This capacitor will be replaced with a battery of 5 volt. Well and good. Battery of 5 volt. This resistance will remain there as it is. This capacitance will be shorted. So what will be the current IR or IC, you can say IR. The same IR current is flowing through the capacitor, right? Okay. One thing here. What was the time constant? 0 second. Okay, we have told. Okay. Yeah. So what is the current at t equals to 0 plus? What is the current at t equals to 0 plus? That is 5 by R ampere, not infinite current. Okay. So the capacitor will hold its voltage. That means VC1 0 plus would be 5 volt and VC2 0 plus would be 0 volt, right? Now what happens? This 5 by R current after t equals to 0 plus, after t equals to 0 plus, this is capacitor C which is having 5 volt. This is capacitor C1. This is resistance R and this is capacitor C2. Now what happens? there is this 5 by R current is flowing, right? This 5 by R current charges C2 and discharges C1, right? This 5 by R current is charging the C2 and discharges C1. Now at what point, till what point there will be some current? This charging and discharging will go on, discharging and discharging will go on until current becomes 0, will go on until IR goes to 0. When IR goes to 0, at what point IR will go to 0? IR will go to 0 if Vc1 is equals to Vc2 equals to some potential. This is Vc1 and this is Vc2. If both of the potential are 0, that means there is 0 drop across the resistance. If this is V, this is V, that means there is 0 drop across the resistor. That means there is 0 ampere current. So if 0 ampere current is flowing through the resistor, that means 0 ampere current is flowing through the capacitor as well, because all are connected in series, right? So if Vc1 and Vc2 equals to 0, that means IR is equals to 0 ampere. That means there will be no current through capacitors, right? So what happens at steady state? So that shows at steady state Vc1 equals to Vc2 equals to some potential Vc. Now what we can do? Apply charge conservation. Right? We can apply charge conservation. So initially we were having 5 into C1 voltage, and then we will be having C1 plus C2 into Vc. Your Vc at t equals to infinity actually. Vc at t equals to infinity would be 5 C1 upon C1 plus C2. Okay. That means it will be equals to Vc1 at t equals to infinity and Vc2 at t equals to infinity. Actually, we shouldn't write Vc infinity, because we should have written here at steady state Vc1 infinity is equals to Vc2 infinity is equals to Vc, right? So this is the condition. So Vc value is rising, this value is going from 5 to this value, but this time the response is not step, it is not going from 5 to suddenly that value, it is exponentially decaying. Why so? What is the time constant? What is the time constant? This is C1, this is a resistance R, this is C2. C1 C2 are in series, so C effective is C1 C2 upon C1 plus C2. What is R equivalent? That is R. So what is the time constant? That is R C1 upon R C1 C2 upon C1 plus C2. This is the time constant. So what is actually happening here? Initially it was having 5 volt. So the current was 5 by R. Now what happens? This gives some voltage to this. Let's assume it has developed 0.1 voltage. So what will be the current? 5 minus 0.1, that means 4.9 by R. After that, let's assume it is developed 1 volt, then the current would be 4 by R. So slowly the current is getting reduced, right? Slowly the current is getting reduced, and C1 is getting also voltage across C1, that is Vc1. Vc1 is also reducing and Vc2 is increasing. At some point Vc1 and Vc2 goes equal. So this is what is happening in that circuit. I hope you have understood the complete concept. I will repeat it once again. Initially C1 was having 5 volt, that means 5 by R current was flowing, that means 5 by R current is discharging the capacitor C1 and charging the capacitor C2. So slowly the VC1 is going down and VC2 is going up. At some point of time, both VC1 and VC2 will be equal. At that point of time, the current flow will be 0. At that point of time, current flow will be 0. And at that is the point when steady state is reached. So this is the point where steady state is reached. You can solve the circuit with Laplace transform as well. How will you solve the circuit with Laplace transform? You will replace this circuit C1 and 5 volt 5 by S volt battery with 1 by C1s capacitance in series. Then resistance R, then 1 by C2s capacitance in series, and then you can solve the problem, right? We will solve by Laplace transform as well. I will just make the circuit, then you can solve. Okay. So yeah, so this is what is happening. And what is the value of IC or IR? IR at t equals to infinity, that is 0 ampere, right? IR at t equals to infinity is 0 ampere. So it is starting from 5 by R and then going down to 0. So first make the graph of IR. What about IR? What about IR? And this is VC1 and this is VC2. What about IR? It is starting from 5 by R and goes down to 0. Okay. With time constant R into C1 C2 upon C1 plus C2. I will also write down the equation of IR from 5 by R to 0 ut. Okay. And here if they had asked you what is the equation of, in the previous problem, here what is the equation of IC1T? IC1T. What is the equation of IC1T? That is minus 5 C1 C2 upon C1 plus C2 delta T, right? And what is the equation of IC2T? That is 5 C1 upon C1 plus C2 delta T, right? And here in this question, the equation is 5R e to the power minus t upon tau ut. What about VC1? VC1 was previously it was 5 volt. It was 5 volt. Then it decays down to some value, but it decays down exponentially, right? From 5 volt to it decays down to 5 C1 upon C1 plus C2. Okay. What about VC1? VC1 slowly it is 0 and then going up to 5 C1 upon C1 plus C2. Five C1 upon C1 plus C2. So write down the equation of VC1T. Let's just call this value as V dash. Okay, because we don't want the equation to be complex. So what is the value of V infinity? That is V dash plus 5 minus V dash e to the power minus t upon tau, right? And what about VC2? VC2 I can directly write, that would be 5 C1 upon C1 plus C2 1 minus e to the power minus t upon tau. Of course ut will be there, and here as well we will have ut. Are you understanding the point? Here the initial and final value are same, but there is one difference in the second circuit, is that the response is exponential. From first circuit to second circuit, there is only one difference, that is the response is exponential. In the first circuit there was immediate response because there was no resistor involved. If there was no resistor involved, that means the current was infinity. Okay, now we will see the example where resistance is involved. Still there will be two kind of response. One response will be exponential and the other response will be the one response will be the sudden rise and the other response will be exponential. So in the third example we will see all two cases. Okay, so I hope you have understood this concept. We can like decay it down to what is the value of v dash, that is 5 c1 upon c1 plus c2. Here we will have 5 minus 5 c2 upon c1 plus c2, I guess, e to the power minus t upon 2 ut, like 5 minus v dash, right? V dash, what is v dash? 5 c1 upon c1 plus c2, that would be 5 c1 5 c2, this would be plus. Okay, because at t equals to 0 you are having 5 volt, yeah, that would be plus. So what you can take in common? Nothing. This is the final answer. Of course you should make it like this. Okay, and this is also to complete ut. Okay, so these are the waveforms. Now we will take the final example, that is our third circuit where both of the responses will come, that is this example. Okay, 5 volt RC2. Okay, so I will draw the circuit. So this was our third circuit. So circuit at t equals to 0. Now tell me what will happen at t equals to 0. So try to solve it on your own. Okay, this is very good example and you should solve it on your own because we have studied a lot of things, right? So the capacitor C1 will be replaced with a single battery. C1 will be replaced with a single battery of 5 volt. This will be replaced with resistance R. And VC2 will be replaced with short circuit. What will happen? Tell me what is the value of current that is there here, here and here. Let's call this current as I and this current as IR. This current as IC1 I am calling. Actually IC1, wait a minute. Yeah, this is actually IC1, this is IC2 and this is IR. IC1 will be negative value of equal 5 by 0, that is infinite ampere current. Why so? 5 volt resistance is shorted, that means total resistance it C from here. What is the total resistance? R parallel with 0. R parallel with 0 will give you 0. So 5 by 0. So 5 by 0, that means infinite current, that is impulsive current. That means sudden change in capacitor voltage. So actually what is happening? Even though there is resistor connected, but at t equals to 0, the value of Vc1 and Vc2 has to be equal. Even though the resistor is connected, at t equals to 0, Vc1 and Vc2 has to be equal to follow the KVL. In the previous question, at t equals to 0, Vc1 and Vc2 doesn't need to be equal, because if this is 5 volt, this doesn't need to be 5 volt. Even if this is 0, it is fine in the circuit. If Vc1 is 5 volt, even though Vc2 is 0, no KVL rule is broken here. If this is 5, this is 0, that is fine, because the 5 volt drop R can take. But in this question, if this is 5 and this is 0, so what it will say? Here it will say, here it will say we have 5 volt, here it will say we have 0 volt. So by this also you can understand that at t equals to 0, they have to change their voltage immediately to follow the KVL. Or also you can see the infinite current is flowing, so it will change its voltage. So how it will change its voltage? Apply charge conservation. So charge conservation, apply charge conservation. So what I was saying, at t equals to 0, Vc1 equals to Vc2 equals to Vc, some voltage. Again I am doing the same mistake. Vc0 plus equals to, at t equals to 0 plus Vc20 plus equals to some voltage Vc. What will be that voltage? 5C1 upon C1 plus C2, that will be your Vc voltage. Are you getting this point? So first what happens, Vc1 goes from 5 to 5C1 C2, 5C1 upon C1 plus C2, and Vc2 goes from 0 to 5C1 upon C1 plus C2. But is that the steady state? Let's see what happens after t equals to 0. After t equals to 0 plus, is this the steady state? That I need to know. This is capacitor C1, this is charged to Vc voltage, right? At t equals to 0 plus, this is charged to Vc voltage. This is resistor R. This is resistor R, and this is capacitor C, that is charged to Vc voltage. So what is happening? And this current I am calling IC1, and this current I am calling IC2, right? This current is IC1, IC2. Now this Vc, here we have Vc, here we have Vc. So this Vc will come across resistance R. Same potential will come across resistance R. So because of this Vc potential, there will be this current Vcr flowing. Vc by R is flowing. Are you getting my point? Vc by R current is flowing, right? Vc potential. So Vc by R current is flowing. Now from where this current is coming? If there is, let's just assume there is some circuit. Here we have 5 ampere current. That means from here some current would be coming, from here some current would be coming, right? These two will make 5 ampere current, right? So if Vc by R current is coming here, that means there would be some current coming from here and some current coming from here. Can you tell the value of these currents? IC1 would be at t equals to 0 plus negative value into C1 upon C1 plus C2. Did you understand it? Let me explain it. Let's assume there is this, okay, forget it. Let's assume there is this 5 ampere current. Okay, there is this capacitor C1 and this capacitor C2. Both are connected in parallel. Tell me what will be the value of IC1, what will be the value of IC2? 5 ampere current. Now both of them will be divided in the proportion, in inverse proportion of impedance. But since they are the capacitance, so the current will be divided in proportion to the capacitance. In case of resistor, what would happen? R2 upon R2 plus R1 in the inverse proportion. But in case of capacitance, they will be divided in the proportion, because the resistance provided by the capacitor is 1 by j omega c1. Or you can say, what will be IC1? IC1 would be 1 by j omega c2. The resistance provided by this impedance, this capacitance. The impedance provided by capacitance C2 upon total capacitance. So if you solve this, you will get C1 upon C1 plus C2. So basically the current is divided into 5 ampere. So basically the current is divided in the proportion. In case of capacitance, the current is divided in the proportion and the voltage is divided in inverse proportion. So the current is divided in proportion, right? So here we are having 5 amp Vc by R current. So some current would be coming from here, some current would be coming from here, right? So 5 by R current would be divided in the proportion. So Vc by R C1 upon C1 plus C2. Why negative sign? Because the current direction would be this. Current direction would be this, but we have made the direction like this, IC1 and IC2. And what will be the IC2 value at t equals to 0 plus? That would be Vc by R C2 upon C1 plus C2, also negative sign. Are you getting this point? Now, what is happening? Both capacitor C1 and C2 are getting discharged. from both of the capacitor, from both of the capacitor, current is flowing outward. Outward. That means both of the capacitor are getting discharged. Right? From both of the capacitor, the current is flowing outward. That means both of the capacitors are getting discharged. Till when it will discharge? The capacitors will discharge until IC1 and IC2 goes to 0. Right? And if IC1 and IC2 are 0, if IC1 and IC2 goes to 0, that means 0 ampere current here, 0 ampere current here. That means IR goes to 0. IR goes to 0. That means if IR is 0, that means the resistance okay, I will write on the next page. If IR goes to 0, that means the voltage across the resistance is 0. If IR goes to 0, that means the voltage across the resistance is 0. If the voltage across the resistance is 0, the same voltage is across the C1, the same voltage is across the C2. So if VR is 0, that means VC1 and VC2 also 0. That means at steady state, VC1 infinity equals to VC2 infinity equals to VR infinity equals to 0 volt. Did you understand what is actually happening in the circuit? First 5 volt, immediately they change the voltage from 5 to, it goes to 5C1 upon C1 plus A2. Now because of this voltage 5C1 upon C1 plus A2, there is some current in the resistor, that is VC by R. Now this VC by R current is coming from two capacitance, that is VC by R into C1 upon C1 plus C2, and from here it is coming VC by R C2 upon C1 plus C2. So two currents are coming. Now what is happening? These two currents are discharging the capacitor. Now the capacitor are getting discharge. Till when it will discharge? Until the current through the both of the capacitor are 0. So when the current will be 0? If the current is 0, that means the current in the resistor is also 0. If the current in resistor also 0, that means what? The voltage across the capacitance is also 0. So this is what is happening in the circuit. Are you able to understand? Are you able to follow up? Very, very interesting analysis it is, right? So we will make the waveforms now. So what waveforms we have to make? VC1, I will see the question first. VC1, VC2, and also I guess we can make IC1 and IC2 as well. So we can make IC1 and IC2 as well. This is IC1, this is IC2. We can make all the waveforms. I will just take this circuit. I will call this current as IC1 and this current as IC2. Okay, so IC1 and IC2 also we can make. If we can make the waveform of IC1 and IC2, then we can make the waveform of IR as well. Okay, so first I will draw the VC1 waveform. IC1, IC2, we can make the waveform of IR as well. Then all the waveforms we will make. First I will make the waveform of VC1. Here I will make the waveform of VC1, and then I will make the waveform of VC2. So what is happening in case of VC1 and VC2? VC1 was initially it was 5 volt, then all of a sudden it drops down to 5C1 upon C1 plus C2. Initially it was 5 volt, then it drops down to 5C1 upon C1 plus C2, then exponentially discharges to 0, right? Exponentially discharges to 0. Yeah, what is the time constant? Tell me. We forgot to discuss the time constant. What is the time constant? Time constant. Time constant. Forget about the initial voltage. C1, C2 are in parallel and R is it's one single R is there. So R equivalent is R and C1, C2 are in parallel. So it would be C1 plus C2. R into C1 plus C2. Right? So time constant is R into C1 plus C2. Okay. So what do you think? What will be the equation of VC? What should be the equation of VC1T? What do you think? How you should write VC1T? I will write it. Look, VC1T. I will write 5U of minus T. This is UT. If this is UT, what will be U of minus T? This will be U of minus T, right? I am saying UT equals to 5. No, not UT. I am saying XT equals to, what I should say, XT equals to T. I am saying XT equals to T. What will be X of minus T? That will be minus T. What is the graph of this? This. What is the graph of this? This. So simply the graph is mirrored. If you take the mirror at y-axis, you will get this graph. If you take the mirror, you will get this graph. So whenever there is negation in the time, that means you will simply mirror. So if this is ut, this will be u of minus t, right? This is ut, then this is u of minus t. So you are having 5 volt for u of minus t. Then at t equals to 0, you are having this voltage and it decays down to 0. So 5 C1 upon C1 plus C2, and that is decaying down to 0 for u of t. Are you getting this point? 5u of minus t plus 5c1 upon 5c1 upon c1 plus c2 e to the power minus t upon tau. What about vc2t? This lecture is actually going to be of 2 hours, I guess. Yeah. So what about vc2t? But I hope you didn't get bored at all. Right? You didn't get bored because this was very interesting analysis. We have seen many circuits and all were very interesting. So from 0 it will start, then it will go up to some value, that is 5c1 upon c1 plus c2, 5c1 upon c1 plus c2, and then decays down to 0. Then decays down to 0. What is the waveform of Vc2t? For t equals to 0 minus, you don't need to write because it is 0 only. So for next analysis only you will write 5c1 upon c1 plus c2 e to the power minus t upon tau ut. This is your Vc2t. This is Vc1t. This is Vc2t. Okay. This is Vc1t. This is Vc2t. What about IC1 now and IC2? What is happening in IC1? First a negative impulse, then negative value that decays down to 0. Are you understanding? Look, it shouldn't be, it is too much, I know, but you should have it. Like if you revise it once again, it will be all clear to you. I am explaining very neatly, I guess. What will be IC1? Here we will have an impulse, right? From 5 to it is going down to some value 5c1 upon c1 plus c2. So that because of that we will have an impulse because of the sudden change. Then Vc1 is going down. That means Vc1 is decreasing. That means we will have a negative current, and eventually the current goes down to 0. Right? So how will that dummy waveform look like for IC1? Negative impulse, then goes down to 0. What about IC2? A positive impulse, because voltage is increasing, then voltage is decreasing, that means negative value, that decays down to 0, right? Or if you already know the VC1, you can simply differentiate it and then get the value of IC1 and IC2. Just differentiate it, you will get the value of IC1 and IC2. First an impulse, then decays down, okay? But we can already know the value by our concepts. IC1, IC2. What about IC1? At t equals to 0, what is happening? At t equals to 0, it is having this impulse. From 5 to it is going down to 5 C1 upon C1 plus C2, right? So the impulse will be 5 C1 C2 upon C1 plus C2 and negative sign will be there. How I have written it? C1 into the change in the voltage. What is the change in the voltage? 5 C1 upon C1 plus C2 minus the initial voltage. So what you will get? C1 into 5 C2 upon C1 plus C2 and negative sign will be there. So it will be minus 5 C1 C2 upon C1 plus C2. Okay. Now at t equals to 0 plus, what is the value of IR? IC, sorry. IC at t equals to 0 plus, that is this value. VC by R into C1 upon C1 plus C2. What is the value of VC actually? Value of VC is 5 C1 upon C1 plus C2. So let's just forget it. We will just write VC by R, C1 upon C1 plus C2. So this is the value and then it decays down to 0. This value and it decays down to 0. What is this value? Okay, I think I can make a better waveform. This is the value. What is the value? VC by R C1 upon C1 plus C2, that is minus VC by R into C1 upon C1 plus C2. What is VC? VC is what was VC? 5 C1 upon C1 plus C2, right? This is VC. Now what about IC2? IC2, initially there will be an impulse. The impulse will be positive. Why so? Because the capacitor value is getting charged. So 5 C1 upon C1 plus C2 into C2. C2 into the voltage it has developed. C2 into the voltage it has developed. It has developed 5 C1 upon C1 plus C2 voltage. Now this current will be there. What is the value of this current? That is VC by R into C2 upon C1 plus C2. Okay. So first it goes like this and then it decays down like this. Okay. So I hope you have understood the concept. This is the IC2 graph. Now we will write down the expression. So what will be the expression of IC1T? Like these kind of questions are asked in the exam, but every time we have solved by Laplace transforms. And if you solve in by Laplace transform, it will be like very difficult for you to answer. Like they will ask you what is the value of current at t equals to 0. So you will solve by the Laplace transform and you will find the answer. But in the exam, if you know, you can simply tell the current will be impulsive. Then they can ask the value of f t equals to 0 plus. You will again solve by the Laplace transform and get to the final answer. But if you know the concept, you can directly tell. So that's why I am teaching so much deep, so that there will not be any problem for you. Okay. So first we are having an impulse, that's of minus 5 C1 C2 upon C1 plus C2 delta t. Then we are having an exponential decaying response. And for every competition exam it is necessary. Like now I have taught this concept, so many of the people will say this is not relevant for gate exam. But if you pick up the questions from past of the question paper, you will see these kind of questions are asked. But every time we have solved by the Laplace transform, so we think that this is out of the scope. But this is not out of the scope. This is in the syllabus. So in the future, you can expect some very difficult question from these kind of analysis. So that's why I am teaching in very deep, and all the subjects will be dealing in the same way. Okay. So anytime any question can be asked in the like, let's assume they are asking some question in gate 2025. They ask this question in gate 2025. The same concept will be there in your notes in gate 2026. But we don't want that thing. जो आने वाला है वो पहले ही सीख लेंगे, right? But what really happens is sometimes like they teach later on, and then they say that yeah, I have taught this concept. But when it was asked, you didn't teach that concept. When it has been already asked, now you are teaching the concept, right? But this we will not let happen. We will not let this thing happen. Okay, we will teach all the concept that is necessary for the exam. Okay, and also for the placements. So this is the expression of IC2T, and this is the expression of IC1T. For IR, I leave it up to you. For IR, initially there was zero current, then suddenly the current was 5C1 upon C1 plus C2 by R, then the current goes to 0. Okay, so IR waveform you can make on your own. I will just write down the equation of IR. What will be the equation of IRT? The current goes 5C1. What is the voltage that we develop? What is the voltage that we develop? 5. What is IR? VC by R. IR at t equals to 0 plus is VC by R. What is VC? VC is 5C1 upon C1 plus C2. So 5C1 upon C1 plus C2 by R. Then it goes down to 0. IR goes down to 0. So this is the expression of IRT. You can make the graph on your own. Simply from here to 0. Right? So this is the complete analysis of all the circuits. You can solve the circuit by Laplace transform as well. Let's just solve one of the circuit by Laplace transform. I will just make the circuit. You can solve the next part by your own. Okay, by your own. Solving the circuit by Laplace transform. Okay, so I guess I can copy the circuit. Tell me how this circuit will be replaced in Laplace domain. This capacitor will be replaced with 1 by C2S and a battery of 5 by S. A resistance R will be there. This C2 will be replaced with capacitance 1 by C2S. Right? This will be your VC1S. Okay, this will not be your VC1 I should write. Yeah. So this will not be your VC1S. Okay, this will not be VC1S. VC1S will be the complete one, because with the battery, because this is also a part of this complete is your capacitor C1. This complete is your capacitor C1. Capacitor C1. Okay. This is resistance R, this is C2. So this will be your VC2S. This will be your actually IC2S, IC2S, and this will be your IC1S. Now, if you need to know the value of VC1, VC2, you can apply the Laplace transform and get to the values. How will you apply Laplace transform? VC1, let's just write it one equation. VC1S minus 5 by S upon 1 by C1S plus VC1S by R plus VC1S by 1 by C2S is equals to 0. From here you will get the value of VC1S, and then you can find the value of VC2S and everything. So that's how you solve in Laplace transform, but this is not how we will be solving, because we have developed our brain, we have developed our concept. We are not just, we are the engineers, right? We are the engineers who don't believe in so much of mathematics. We believe in mathematics, but not so much of mathematics. When we can solve by your brain, by using our concepts, then why not solving the, why not we should solve the question by the concept? Why should we apply needless mathematical equations? Okay, so that's how you'll be solving in exam. They won't ask you that much deeper in exam, but they can ask you anything from this. Okay, so you should be able to write it down, and you will be able to answer very quickly if you have understood the concept very deeply. Okay, so I hope you have understood the concept. I hope you have enjoyed the 2-hour lecture. So it was an extensive lecture. Okay, so you must have gained a lot of knowledge. So there are a few more circuit left. I will deal those circuit, and then we will move on to our questions. Okay. Okay. So meet you in the next video. Thank you.